Hey, all, today we are going to continue talking about similar triangles, and we're going to talk about some shortcuts to show that triangles are similar. Um, this is, and no pun intended here, this is similar to when we use shortcuts to show triangles were congruent. When we showed triangles were congruent, we needed some combination of pairs of sides, pairs of angles, and there were 5 ways to show that triangles were congruent only by knowing 3 pieces of information. Well, the same is true about, showing they're similar, except there's only 3 different ways. And so, of course, let's recap what it means for triangles to be similar. The first thing we know about similar triangles is that corresponding angles are congruent. So we still have a congruence piece to this. The angles that correspond from one triangle to the next are congruent. And then the second thing we know is that the corresponding sides are in proportion. So remember that in proportion means that the fractions are the same. So we take a side from one triangle, match it with its corresponding side in the other triangle, and we write a fraction. And all 3 of those fractions should be the same. They might not look the same, but if we put them into a calculator and simplified them, they would simplify to be the same thing. So there are 3 ways to show triangles are similar. And just like I said with congruent triangles, the method that I choose to use is to write all the options every time. So we have the side angle side method. And we typically put a little squiggly because this little squiggle means similar. Okay, we have the congruence, that's congruent, the squiggly with the equals. Just the squiggly means similar. So we have side angle side similarity, we have side 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 similarity, and then we have angle angle similarity. And side 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 angle side, they look really close to what we had when we had congruent triangles, except this time when we talk about sides, we're not talking about them being equal, we're talking about the fractions being equal. And then when we have angles, we're talking about, hey, this angle corresponds to this angle, they're the same size. So, and then of course we always have the option that we don't have enough information, NEI. So I want to see if these 2 triangles are similar, and I like to eliminate possibilities, just like I did with congruent triangles, and then we can check to see if the possibilities remaining work. So I look at these 2 triangles and I see that in each of the triangles I have 1, 2, 3 sides labeled with a measure, 1, 2, 3 sides labeled with a measure. I don't have any markings in any of the angles. There's no red arcs like I have over here to show that angles are congruent. So what I'm going to do is go ahead and straight away get rid of these 2 options that require congruent angles. And so now I can check to see if the corresponding sides make the same fraction. I always like to do small over big, so these sides are smaller. So I'm just going to list them from smallest to biggest, so 7, 12, 13. 7 is the smallest side in this triangle, so if this triangle is going to be similar to this one, then this smallest side should be related to the smallest side in this triangle. So that would be 63. So I'm going to write that fraction, 7 over 63. 12 is the medium side, so it should be related to the medium side over here, 108. So I'm going to write that fraction, 108. And then 117 and 13 are the biggest sides, so I'll write that fraction. Just like in the last lesson, remember that all the numbers on the top of my fractions come from the same triangle. All the numbers in the bottom of my fractions come from the other triangle. I'm going to pause here and I'm going to pop these in the calculator and see what decimal I get, because if they're the same decimal, then that means those fractions are equal. So you can see I've put all 3 of those fractions into Desmos, and you can see I get the same decimal, 0.1 repeating for all of them. That means even though these fractions look different, they are all the same. And I can actually, if I press this button, it'll give me the simplified fraction. They all simplify to be 1 over 9. That means they're in proportion. So all three pairs of corresponding sides are in proportion. That means we have the side, side, side similarity. This 1 over 9, by the way, is what we would call a scale factor. And so the final thing we want to do here is name the other triangle. We name them like we name congruent triangles. We need the appropriate letters to match up. So I have F, G, H. This can be a little bit trickier. FG, that is our smallest side. And then when we follow the pattern FGH, we go across our smallest side and then across our medium side. And so when I name this one, I want to go across our smallest side and then our medium side. So I'm going to call that FRS. If that's challenging for you, tricky, you need some help on that, please do ask me for help and I can try to explain that in a different way. So I'm going to do a couple more of these and then I'll give you a chance to try one. I'm going to write down all my options. It's important that we remember what options are available here because they are similar to the options we have for congruent triangles, but they're not the same. And so we want to make sure that we're remembering which ones apply to similarity. That's helpful because we put the little similar symbol. And I do still look for things like reflexive property and vertical angles. I have some vertical angles here, so I'm going to put 2 arcs in there. I don't know anything about the sides in these triangles, so I'm going to get rid of my options that need sides to be matching. So my only option here is angle, angle, or not enough information. Angle, angle means that I have 2 pairs of angles that are congruent. Remember, angles are congruent in similar triangles. So I have B and K, they're congruent. L in both triangles are congruent. I have 2 pairs of congruent angles. That means I have the angle, angle similarity. And so I can finish this statement. This goes L, K, J, and you can see I go from my 2 arc to my 1 arc. So I'm going to go from my 2 arc L to my 1 arc B, C. So let me do one more here. There's going to be some on here that I'm not going to do, but that's okay. They're available to you if you want to try them. Again, I'm going to write down my options. And then when I look at my triangles, they're not overlapping in any way, so I don't have vertical angles. I don't have any reflexive property. And in each triangle, I have 2 sides and that I know the length of, and 1 side that I don't. So side, side, side is not going to work for us. I need to know about all 3 sides. In each triangle, I have 1 angle with 1 arc in it. So that means angle J and angle C correspond, and they're the same size. But I only know about those angles. I don't have a second pair of angles, so angle, angle will not work. In order to be side, angle, side, the angle has to be between the sides. Angle J is between these 2 sides. Angle C is between those 2 sides. So far we're on the path to side, angle, side. And then the other thing that has to be true is the corresponding sides have to make the same fraction. So if I take the smallest side 16 in this triangle and I divide it by the smallest side 24, and then the bigger side 18 divided by the bigger side 27, I need to check to make sure those are the same fraction. If they are, then we have side, angle, side. So I'm going to pop those in the calculator quick and then show you what I got. And as you can see, they are the same fraction. If you're using Desmos, you can convert them to, I'm sorry, they were the same decimal. If you use Desmos, you can convert them to the same fraction. 2 over 3, that's our scale factor. We have 2 pairs of sides that make the same fraction. With a congruent angle in between them, we have side, angle, side similarity. So I just want to show you a couple of things that come up when we're looking at problems like this. I'm not going to decide whether or not they're similar right now. I just want to show you what some of these things mean. If you can remember back to earlier in the year when we had these triangles like this, that meant those two lines were parallel. And so what this ends up causing is some congruent angles. So we knew that when we had parallel lines, and a transversal. So if this was a transversal and we drew these lines out longer, we knew that this angle and this angle were called corresponding angles, and so therefore they were congruent. And that also occurs right here when we have this transversal in this line and this line that are parallel. That angle and that angle are congruent. And so parallel lines tell us about congruent angles, and if we have two pairs of congruent angles, then we know that triangles are similar by angle angle. We also have reflexive property that can exist. It doesn't just apply to side lengths, it also applies to angles. So if we share an angle, then that means we have reflexive property. So if I look over at this pair of triangles, I have this smaller triangle, and then I have this bigger triangle. And in both of those triangles is angle L. And since angle L is in both of those triangles, angle L must be the same size both times. And so this is an example of reflexive property. So we could put an arc in there and say that we have a pair of angles that are congruent. L, if I were to take the yellow triangle out from the green one, L would be the same size in both. And so therefore we have a pair of congruent angles, and that is an example of reflexive property, this time using angles. So I just wanted to point out a couple of those things that might appear in conjunction with similar triangles. So of course, as always, if you had any questions throughout this, or I can clarify anything to you personally, or maybe as a whole group, please ask me. Write down your question if you don't want to pause in the middle and you want to ask me at the end. And of course, it's really important that you practice these things. It's really important that you do this many times. Write down the options every time. That's how you get better at this. If you need help, ask, and good luck.